Alright, pre-calculus. Let's see what we can do. We are graphing rational equations. We have to identify the holes, the x and y intercepts, vertical and horizontal asymptotes. I do not know why I'm talking like this, but oh well. Looking at this, I don't like I want that there. So I'm going to put the negative there. I'm going to factor the bottom because it will help me. Quit laughing. Okay. Are there any holes? No, nothing cancels. X-intercept. X-intercept is when the numerator equals 0. Will the numerator equal 0? No. Negative 4 cannot be 0. There's no x-intercept. Y-intercept is when the plug 0 into x, what do we get? Plug 0 into x, what do we get? Well, if you plug in 0, go here. 0 minus negative 4 over negative 9. Y equals negative 4 over negative 9, which is 4/9. Y equals 4/9. Almost 1/2. So let's go to 1/2 and put a dot right there. X-intercept, Y-intercept, piece of proverbial cake. Vertical asymptotes. That is when the denominator equals a 0. Well, right here, this will be 0 at negative 3, and this will be 0 at positive 3. X equals negative 3, x equals positive 3. So I go here to positive 3, and I go vertical border, just like in Mother Russia. And this is negative 3, vertical border. You cannot cross. Boom. Look at that. You're stuck. Iron curtain. Horizontal asymptotes. That is by degree, and we have different cases. This one happens to be case 1. The denominator is degree 2, numerator degree 0. If it's case 1, y equals 0, which is another name for the x-axis. Look at that, they turned off my air conditioning, just like in Mother Russia. Now, how do we graph this? There's no x-intercepts, so I'm pretty positive that this is going to be a loop. But to figure it out, I will plug in some points. I'm going to plug in 1 and negative 1. I'm going to make a table. 1 and negative 1, see what's happening. So if I plug in 1, let's go here. I get negative 4 over negative 8, which is positive 1/2. If I plug in negative 1, that's positive 1/2. So both 1 and negative 1, positive 1/2. Since they're both 1 and negative 1 positive, a little bit more. This is not 1/2, it's close, but a little bit more. But they're both above, so I'm just going to come hug up here. Come hug a polar bear. What about the other sides? I think they're down here just because of experience. You grow up in Russia, you get experience. So I'm going to 4 would be a great point because it's above or below, and negative 4. So I'm going to plug that in here. 4 squared is 16, minus 9 is 7. I get a negative 4 over 7. I get the exact same if I do this one, which means I'm below the graph. So I hug this one and that one, and it should look just similar to that. Doesn't have to be exact, you want general idea. I go now. That's enough. Okay, my turn. my turn here. Let's do this one. Ooh, look at that negative x right there. Oh, I don't know. Well, let's just do it. The x-intercept. Okay, that's when the numerator was 0, right? Okay, so when will the top equal 0? Now, it might throw you off, that negative x. Negative x plus 3 equals 0. That means negative x equals negative 3. That means x equals positive 3. So it's going to cross the x-axis at positive 3. That's exciting. So now we go with the y-intercept right here. Boom. That's when you plug 0 in. Well, if we plug in 0, we get 3 over 1, so y equals 3. So y equals 3. Now, don't confuse these two things, will ya? It's not a single point. You don't put a point over here at 3, 3. That's not. It's 1 on the x-axis, 1 on the y-axis. Let's get it straight, people. Nothing cancels, no holes. I should have said that earlier, but the vertical asymptote is when the denominator is 0. That's easy. X is negative 1. When will the denominator be 0? Negative 1. So we're going to put a border at x equals negative 1 right here. What do you think? Negative 1. Okay. And then the horizontal asymptote. Well, that's degrees, right? And this is case 3. Degree 1 and degree 1. So what are the coefficients? The top coefficient is negative 1, the bottom is positive 1, so y equals negative 1 is my horizontal. Negative 1 is here, and that's y, so we go like that. Now, I know how to graph this. I know how to graph up here because I got 2 dots, so I'm going to hug that right there, come around and hug that right there, boom! Look at that, that's just exciting, exciting. I'm not sure what to do here. So maybe we plug in some points, but it's a little tricky with the negative with the minus x. So if I plug a negative 2 in, well, I am sure what I'm going to, I am sure. I don't have to, I can plug a negative 2 in. That's going to become a positive 2 plus 3 is 5, and negative 2 plus 1 is negative 1, so 5 over negative 1. That negative 2, it's negative 5 down here. So I can plug in a number and find out, oh, I'm down here. But look, if I were graphing next side by side, then I should have another x-intercept. I don't have another x-intercept, so I can't be there. So I got to go, wah, like that. What an exciting time that is. Whew. All right, let's do this one. Figure it out. Figure it out. Let's see. One of the things we should do is we should, factorize this into something else, like it's always good. This will be good for the horizontal, but nothing else. So what times what is 2, but gives me 1. I think that's x plus 2, sorry, x minus 1. What times 1 is 6, but gives me negative 1. How about an x plus 3, x minus 2? Any holes? No, nothing cancels. So x-intercept will be when the numerator is 0. There are 2 of them. Numerator will be 0 at x equals negative 2, right here, and x equals positive 1. So I'm going to put 2 dots, one at the negative 2 and one at the positive 1. Y-intercept, I got to plug 0 in for x, and I'd rather do it here because 0, 0, 0, 0, I get negative 2 over negative 6, which is the same as 1/3. So I'm going to go to y equals 1/3 and put a little dot there, estimating. Vertical asymptote, when the denominators equal 0, so negative 3, positive 2. Negative 3 here, positive 2. So I make the borders. Wah, 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 wah. There's negative 3. And positive 2, positive 2. Oh, right there. Wah, 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 wah. X equals positive 2. So it looks like I got a curvaceousness. I'm going to just go ahead. No, I'm not going to go ahead. I'm not going to do it. I'm going to hold off because I haven't done the horizontal asymptote. Okay, got this one. What do you do? That's degrees. We can go back here. Degrees are the same. So that's case 3. KC3. Degrees are the same, so we do coefficient over coefficient. 1 over 1 is 1. Y equals 1. It goes right here. Boop, 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 boop. Y y equals 1. And looking at that little curvaceousness right there, it's going to come in here, and it's going to do kind of loop. It's not exactly a parabola, but it kind of goes that way. And then I know that it has to be here, and I know that it has to be here. I know it. Why do I know it? If it weren't, I would have more y-intercept. This is the x-intercepts. These are the x-axis right here. And if I'm below that yet red line at y equals 1, I'm going to have to cross that x-axis again, and that's not allowed. There's no more x-intercept. I don't know what you're going to do with me. All right, peace to you. Peace to you. Let's do this. I will factor. Take a 4. X minus 2. This is going to have an x and an x and a 1 and a 2, and I think it has to have both of them negative. Yes, it does. Now we get that. Woo! Look right away. Cancellation. You know what that means? That means whole. We finally get a whole. So the x-intercept, the y-intercept, and the whole. I'm going to do the whole first. So excited. So x equals 2. X minus 2 equals 0, so x equals 2. Let's plug 2 back in here. 4 over 2 minus 1. Y equals 4. So my whole is at 2, 4. This is the only place, the whole is the only place you use as an order pair. Order pair 2, 4. Boom. I got a hole. I got a hole. All right. X-intercept is none. Why? Because that's where the numerator equals 0, and it does not. Okay, y-intercept, plug in 0 for x, we get negative 4. So let's put a dot at negative 4. Vertical asymptote. All right, this is good. So x minus 1 is 0, so x will equal 1. So we get a border right between. That's so special. And then we get the horizontal asymptote. Just so exciting. When is the, well, the degree of the top is 0, degree of the bottom is 1. Degree of the bottom is bigger than the top, that's case 1, bottom bigger. So when your bottom is bigger, y is 0. X-axis. Oh, we got the graph. We got it. We got to go through the hole, kind of, sort of speaking. Okay? Not actually through it. And this isn't a hole, but we're going to go there. We're going to curve here. Whoop! Whoop, 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 whoop. How's that for hot dogs? Last one. Go Dodgers. Now, in this one, I happen to know, I believe, that there is a slant. Not horizontal, but slant. Well, this is case 2. Degree of the top bigger than the degree of the bottom. Case 2. No horizontal, but it is a slant. So we're going to do that. Before I do this is x minus 4, x plus 4. And then on the bottom, I'm going to take a negative 4 out, and that's x minus 2. Nothing cancels, no holes. Let's give it some space. X-intercept, y-intercept. No holes. So let's get into this. X-intercept, numerator 0 at x equals positive 4 here, negative 4 there. So y-intercept, let's plug in 0. I like to go back here. Plug in 0, get negative 16, plug in 0, 8. Negative 16 over 8 is negative 2. Vertical asymptotes, we still have those. But then we are going to get a slant or oblique asymptote in this case. So, vertical asymptote, denominator is 0 at 2. So, boom, vertical, boom, 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 x equals 2. Now, do you remember how to do the slant? Yes, that's right. We do long division. We divide these things. All right. So we take negative 4x plus 8 into x squared. Now watch this, watch this, watch this, watch this, watch this. Plus 0x minus 16. Remember, you have to count for all the powers of x to make it look good. All right, so x squared, so this is going to be freaky. I'm going to use the bottom of my page a little bit, if you don't mind. I'm going to take x squared divided by negative 4x, and that gives me x over negative 4. Interpreting that, being a 1x over negative 4, that's a negative 1/4 x. Right here, negative 1/4 x. Now, multiplying, I got to distribute that to both of these, which isn't so bad, because the 4 will go into the 4, negatives will cancel, and I'll get just, let's go with this color, just x squared. The 4 will go into 8 2 times, giving me a negative 2x. Do it on the calculator, I'm right. When we subtract both of these, canceling that out, we end up with a positive 2x minus 16. So now we do that again. Take the 2x over, we take the 2x over the negative 4x, which x is canceled, we get negative 1/2. So that means I get a minus 1/2. And that's really all I need, but I'll continue just so that you know that I know that I know that you know that I know. Half of 4 is 2, and the negatives cancel, so we get 2x. Half of 8 is 4, and we get a negative. Then we subtract both of them, cancel, and so my remainder is negative 12, but I don't care about my remainder. I care about my quotient. And so my slant asymptote is the equation y equals negative 1/2 x, 1/4 y equals negative 1. It's all good. It's all good. Happy accidents. Okay, Bob Ross. Okay, my equation here is that, which m, y equals mx plus b. M is negative 1/4. B is negative 1/2. I don't really like the negative 1/2 part, you know, but let's do it. All right, b is negative 1/2. Negative 1/2 is right there, right in the middle. And then I go down 1, right 4, negative 1/4. So down 1, if I'm at negative 1/2 and I go down, oh my goodness, the lights went off. Do that to me again, I'll show you. Down 1 is going from negative 1/2 to here. That's 1. And then to the right 4. 1, 2, 3, 4. Down 1, 1, 2, 3, 4. So I'm using the halves. If I go down 1, I go from one of the half marks to another half mark. And then I draw, it is a border. I'm turning it because that's what you do. And it is a border. It's not a line, it's a border. This is my slant asymptote. Y equals negative 1/4 x minus 1/2. So my slant asymptote just tilts instead of horizontal, it goes slanted, and I know exactly how I'm graphing. I got a dot up in here, so I'm going to get close to that, turn, and come down like that. And I have 2 dots, so I'm going to stay close here, hit both of those, and come down and turn like that. I didn't have any holes. Too bad. Okay, but when you look at that, it just takes, instead of horizontal, it tilts it. But you do that by doing long division. Okay, you do long division, and then whatever the quotient is, that's your equation. Hopefully it's y equals mx plus b. So you draw your line, but it's a dotted line because it's a border. There you go. That was only 5 questions. I hope that really, really helps you.